Hello and welcome back to the channel. Thanks for joining me again. This is the tutorial I think a number of you have been asking for, which is a Godot tower defense tutorial. This is something I did in Unity. It got particular attention because the maps that get generated are random, as you can see here. They have a minimum length, and basically every time you play this, it will be a different map. And this is what we're going to try and do today. We probably won't get this far. I did reach out to you and ask you how you prefer these tutorials to be. Do you want them to be long, massively long ones, short ones, whatever, edited? I think I got a mixed review. So what I thought I'd do is I'd get the basics of the plumbing going. I don't know if we'll get it to look quite as good as this today, but we will get a long way about getting the path in place and looking correct, and just kind of the design and whatever. So that's what we'll do. And I'll give it a bit of an edit. I might even speed it up just a touch, so there's no hanging about, and you guys can get on with it. Because I've checked the stats. People don't tend to watch more than about 10 minutes of my tutorials. I don't know why that is. Maybe people watch it, realize they don't. It's not for them. I'm not sure. Find me too boring. I don't know. Let me know. Let me know in the comments why you clicked away. So before we continue, let me give a quick shout out to Alex. He's asked me for a shout out, and absolutely no problem, mate. If any of you would like a shout out, let me know. I hate to do that, tell a joke. Just keep it safe, keep it child friendly, because I don't want to offend anyone. So let's crack on. What we'll do first of all, let's create our project, and then we'll start thinking about importing the assets into it. Okay, so here we are at the project screen. So I'm going to click on new project here. Let's just call this tower defense tutorial. And I must work out how to default that to /Godot, because it's annoying to have to type it every time. If I go on create folder, there is already a folder in the path. Okay, so I'm going to call it tutorial 2. Okay, you can call it what you like. You won't have that problem. I've been practicing, as hopefully you'll appreciate. I didn't just fly straight into this, so I know roughly what I'm doing. Okay, I will put it in Git. I will upload this to GitHub and put a link to it below so that you can upload it as per each tutorial and kind of stay in line with what I'm doing, or you can download the whole thing at the end if you like. Entirely up to you. So let's click on create and edit. And let's import the assets we need. So if we head on over to Kenney.nl, one second. Okay, so this is Kenney.nl. If you haven't heard of Kenney, then you need to get over here. Again, I'll put a link to this one. Some absolutely cracking assets here. You could just so many to choose from for 2D and 3D. The problem I have, of course, with these animation and asset packs is that you're limited to what you get. And it means that if you do want to do something else, add another asset of some sort, you are somewhat struggling. Like I'm somewhat struggling to say that. You are somewhat struggling to actually get the assets that you need. You might have to do it yourself or something. So that's the thing about asset packs. But this is actually a very good one. If I just search for tower defense here, I've used this. This is exactly the same one that I used in my Unity tutorial. And you go ahead and click on download. I've already done that, and I'll show you that on the... I've downloaded it to the desktop. Hang on 1 second, I'll find that. Okay, so I've downloaded the zip file, I've unzipped it, and I've copied the models folder to my desktop. The ones that we care about are going to be the GLTF format ones. If I just go in here, you'll see there's a whole load of them here. Now I know sometimes if you click on it, it'll load it up. Oh, there we go. It's actually doing it. This is quite good. Windows actually works for a change, and you can actually see what they look like. They're not coloured, which is a little bit annoying, but you can at least see what the assets look like. They will be coloured when they come into Godot, however. So if we go back up to the models folder, and what I'll do is I'll literally just copy that, or drag it straight into the resources here, and then click on back to Godot, and that will start importing them. Okay, there we go. And what I'll do is, rather than call that GFTL format, I'll call that something like assets. And we're done. Right, okay. I noticed this last time. If you move them to a subfolder and whatever, here we go. So we've got all of our assets in there now. And if I was to drag one of the tiles, say, if we search for tile here, and pick up, I don't like the snow one. So let's go for tile corner outer and just drag that in. You can see, there we go. That's what it looks like. We'll be generating links to these so we know which ones to use. There's probably a whole load of these that we won't use. Simply because they just don't need them. I noticed there's, like, for instance, lots of different corners you can use. Corner large, corner round, corner square. So we won't use all of those. So potentially we could delete half the stuff that we don't need. But I hope I don't think we'll need to do that. We can keep them there for now and worry about that later on. All right. So with that all in, what we now need to think about is how we're going to generate a path. How are we going to generate that left to right path that we showed earlier on when I was showing you the routes that were getting generated by my path generator? Well, There's no better way to start than creating a class called path generator, is there? So this is gonna be the one thing that handles our generation of the path. So let's just create a new folder called scripts, and in that scripts folder, and that's gone under assets, has it? You monkey. No, where'd it go? Sorry, it's because I've got tile here. There we go. Clumsy me. Right, there we go. I will be editing some of this, I swear. Some of these mistakes. Right, so if we now click in here, just right click on it rather, and just create new script. And we will call this script, what should we call it? Path generator. So it's just called path underscore generator. It doesn't need to inherit from node. It can inherit from object, which is the root of GD scripts hierarchy. And that's absolutely fine. Template object empty, I guess. And you just click on create. And now if we go into scripts, double click path generator, we've got our script ready to go. Okay, so this is what things we're going to call. We'll just give it a class name so that other things can call it. Class name path generator. Again, in Godot, there's this sort of what formatting system do you use? Well, I tend to try and keep file names all lowercase and folders all lowercase, and I use this sort of uppercase system for classes and what have you, and then here I'll use uppercase, and then functions I tend to use lowercase. I don't know if that's 100% accurate. I'll let you be the judge. There is no real ruling around how you do this. Just try and keep it consistent. So classes have constructors, and let's just have a think of a few of the variables we're going to want for our path. We're going to have a grid length, aren't we? A grid length, and notice that I put an underscore in front of it. So what that means there is that there is no concept of private variables, at least I don't believe that to be the case in GD script or Python or whatever. So the way you tend to highlight something to be private, as in nothing can access it outside of path generator, you put an underscore in front of it. This is going to be an integer, and we can default it to 16 or something like that. And then we'll put the var underscore grid height, type int, equals to 9. Let's make it 16 by 9. Maybe that'll help for the widescreen TVs. Okay. And now what we would do is we would create a constructor, and constructors are var func underscore init, and we're going to want to that constructor is going to have length and height, isn't it? So we'll have length type int, height type int. Now, I don't know that you need to put the code on int at the end there, but it's a hint, and I think it's not always what's the word, validated, but for now I'm just going to go with it in case they do actually make it a bit stronger later on. So func underscore init, and then we'll say underscore grid length equals length, and underscore grid height equals height. And what we're going to have in here as well is a path, I guess, right? Now paths in Godot, at least the way I've been implementing it, is we're going to be using a vector2, an x and a y. And to go a little bit further, there's a thing called a vector2i, which means that they have to contain integers. So you're going to have 2.1 and 3.5. It's 2 and 3, right? So that is exactly what we're after. So we'll have a var underscore path of type array of type vector2i. Have I got that syntax correct? It looks like I have. Hooray, hooray, hooray. Right. So let's do this. Let's now create a function called generate path. So let's just do func. We would want outside classes that use this to actually have access to this. So I won't put an underscore in front of it. So I'll just put generate path. For now, I don't think there's any variables that we need. In case this has been, the path already has anything in it, let's just clear it out. Path.clear. Right. This is a case if we regenerate the path, like I showed you in my at the start of the video, you'll notice that it kept regenerating paths. That's because I was refreshing it, and the way I did that was to do the path clear and then regenerate the path again. So what we need to think about is we say, well, okay, starting on the left hand side, moving to the right, and we need to think about, can we go left, up, right, up, right and down, or down and up? There's a few rules we think about here. Like for instance, if we've just gone up, then we can't go back down again. That would make sense, wouldn't it? Otherwise, we'll kind of go backwards and forwards. So there's certain rules that we need to apply here. So let's just start thinking about what options we have. Well, let's create a possible set of choices. So we'll say choice equals random. Rand I range. Okay, and then we'll say from 0 to, so we'll make 0 right, 1 up, and 2 down. And the way Godot works, unlike some languages where actually 2 would never be selected, this will actually say it could be 0, 1, or 2. Right? So choice var choice type int equals rand I range 0, 2. Right. Okay, this is good. We need a starting point as well, don't we? Let's just have a think about that. Hang on. So we need to say var x equals 0. That makes sense, right? We're going to start on the left-hand side. Var y, well, that's the height, isn't it? So that's going to be that over 2. So if we just say var y, and we need it to be an integer, don't we? So we say var y equals int grid height over 2. Now I think that. Why is it asking me to save? No, I've saved scene as well. Just do Control S. Sorry. Save scene. Oh yes, okay. The scene isn't saved yet. Don't worry about that yet. Right. Okay. We can quickly do that. Shall we? Let's just make that main for now, and then we'll just save it. Why don't we create a folder called scenes? There's nothing in here at the minute, but let's just do that anyway. Main.scene. Fine. That'll shut it up. Right. Okay. So yeah, we're gonna move left to right. So let's just what we can do here is we'll say while x is less than grid length. Back it in. Am I going to be kind? Yeah. We're going to create a choice so it can be right, up or down. Now, the one thing that I've done in my path previously is that every other square has to be a right. And the reason I've done that is so that there's always gaps that you can put in turrets. Otherwise, there is the potential that it could go up and down, or in such a way that it would be nearly impossible to place turrets. So I've said that every even turret is a right-hand turret. So that you again look at the start of the video, you'll see what I'm talking about. So if I for now, let's just create a path, very, very simple one. Let's just say we're literally going to say, let's just put here actually, first thing we're going to want to do is underscore path append, isn't it? Append vector 2i x comma y. And for now, all we'll do is just go right, left to right. So we'll just say x plus plus. So every single one's going to be a right-hand one. All right. So the path, and you can't say x plus plus. It's x plus equals 1. All right. And so all that will do is we'll just create a path array of it'll be 0, 4, 5, 0, 5, 1, 5, 2, 5. So let's just do that. Let's just do up in our main. Let's create a script here that uses this. Let's at the end. Let's return it as well. So we'll return underscore path. This isn't a particularly so that choice at the moment doesn't do anything. So let's comment it out with Control K. Trying to use the shortcut keys. So let's go back to our main here and let's generate a script here. That does need to be a no 3D. And main.gd is absolutely fine. And it's created us a ready function and approach. Should I just make that touch bigger so you can see what I'm doing? There we go. So here, we're going to want to create a reference to our path generator. And what I think I might do is I might actually make the width and height available to the editor, so to the inspector. So we'll say export var, what should we call it? We've got map length, type int equals 16 here. Do you know what? That makes me think that in here I should just not have those. I won't do. I'll leave them blank and I'll make it in here. I'll make the default in here, and I'll do the same. Map height. Type into and make that 9 there. And in the ready function here, we will say, let's just have a var PG. PG for path generator. I don't love that right now. We'll work on that. Equals path generator dot new, and we need to pass in map length, comma map height. Yeah, good, you're happy. And what we'll do is we'll just do print pg.generate path. Lovely. Now, if we run this, I can't expect to see anything on the on the screen, but we should see something on the output. Select current is absolutely fine. And if we just ignore that and go, in fact, we can close it, right? And sure enough, as I thought, 04142434, blah, blah, blah. Right, so we've got ourselves a path. That's really good news. So let's just do that rule that I just said a minute ago, that if it's 0, 2, 4, 6, 8 or so and so, whatever, we'll just have here. Well, let's just start it off. Let's just say, let's make 0. If 0 is the choice, then we'll go right. Okay, so we'll say, and now we need to control K there. So we'll say match. No, forget that. We'll do an if. If choice equals 0 or x% 2 equals 0. Right. Now, one thing that I thought about this is it is possible in the way that I've designed this that it could go through this while loop and actually not hit any of the correct choices. You'll see why a little bit more. Now, if we did that, then when we go back through the while loop again, it could potentially re-add the same path slot. So let's just be careful. So we'll just say if not underscore path dot has, and then we'll say vector2i x comma y. I don't like the speed that disappears. There we go. Makes me nervous. Right, so this is good, isn't it? So now we'll have another one. We'll say elif choice equals 1. Then we'll say, now the one thing to remember about the grid maps and X and Y is that a plus is going down. So 0 is at the top, 1 is below it, 2, 3, 4, 5, 6, right? So yes, top left is 0, 0, bottom right would be 16 by 9. Right. Yeah, so what we'll do here, so we'll say for now, if its choice is 1, then y plus plus. And then elif choice equals 2, y minus minus. Now this is going to be a mess. This is going to be a mess because, like I say, it means that we're not checking at the moment to see if we're going down and then up and up and then down. But let's just run it now. What's y plus plus? Y plus equals 1. Good. Right. If we run it again, now I'm hoping I might be able to show you what I'm talking about. 2, 3, 6, 3, 7, 5, 6, 6, 6, 7, 6. Here, I think this is showing. Now these are all going right. 7, 7. It's being okay, I think, but I'm very sure it's possible that it could go up and down. So 5, 12, 5, 13, 5, 13. You know, I don't think that has gone up and down. I struggle to believe it, but let's just run it one more time. 2, 3, 3, 3. There we go. I think that's gone up and down there. Like you can see, it's gone up and down. So maybe you can work this out. It'd be a lot easier if we could visualize this, wouldn't it? So let's think about how we visualize it now. Let's get these onto the 3D screen. So if we go back to 3D here, what I might do is, yeah, all this is going to do, all the path generator is going to do is generate the path. It's not going to be responsible for laying anything out onto the screen. So it's going to be the main script here that will be responsible for that. So if I click on main over here, by the way, you can see in the inspector we've got our 16 by 9. So what I'd like to do is I'd like to get a tile that we can actually use and view. So let's do that. Let's get back to the script, this one here. We don't need process right now. And I'm going to create a at export var. We'll call this path tile. I'll definitely rename that of type packed scene. Packed scene. There we are. Right. Okay. So that's the variable we're going to use. We'll definitely want more than that, but let's just start with that. And now if we go back to the inspector here, you'll see the path tile is empty. And what we'll do is we'll go to our assets folder here, look for tile, and I think literally there's one called tile. This is the very basic one. I can drag that and just drop it in. Bang. All right. And what I'll do in here is I'll have a function called display path. And we need to think about this, and that will take. See, we've got our PG variable here, so let's have this up here. Var PG, which is a type path generator, and then we'll put underscore PG here. I don't love that variable name, by the way. PG. You're going to be asking later on what that means when you look back at the code. But I didn't want to call it underscore path underscore generator. Oh, I might do rename that in a second. So let's under here we'll just put display path there, and we will say we need to do the instantiate. So hang on a second, let me get the code for that. Okay, before I do that, thinking about it, I need to move this down, don't I? To there. I use Alt up and Alt down, by the way. I'm trying to use all of these shortcut keys that I was showing a YouTube short on the other day. Have a look at that if you get a chance. Yeah, so let's generate the path. So we'll just say var path of type array of type vector2i equals, I think that's all we need to say, and that should work fine. Doesn't have an opening counterpart. What have I messed up? Oh, we have too many brackets. What's that? Yeah, lovely. And now what we can do is we'll just say for element in underscore path. Yeah. And let's just print that. I'm not completely convinced that's going to work. Let's just see. For element in path, let's give it a go. There's no errors yet. No, nothing's there. Okay, 1 second. I think I know what the problem is. I think we need to remove that, don't we? We were already using it. It's dangerous stuff. That I often do that. Let's just see if that helps. That hasn't helped at all. It certainly helps if you call the function underscore display path. There we go. Okay, and now we'll run that. That's good. There we go. We've got all the elements in there. Well, I can see one problem already. Look, we can see that we've actually see there's -1 there, so that means the y has gone above 0, so to speak. We can quickly do a change on that, can't we? So the y minus equals 1 there. So we'll just say and y is greater than 0. That will stop it going above. Into negative numbers, and we should do the same here, shouldn't we? And y is less than underscore grid height, so that will stop it going too high or too low. Let's give it another run. We're in good shape here by the looks of it. I think this is going rather well. So what we'll now do back in main here is we will instantiate them and place them onto our 3D scene. So we'll just say element dot instantiate. Now we might need to give it a no. That's so the no. I'm being a fool. So the element is the actual path, isn't it? Is the vector2i. Can I do that? No. Okay. So let's just do for element in path. We'll say so it's element dot x. Oh, okay. So it doesn't know what the element is. That's good. Right. That's fine then. So we need to instantiate. So we're going to say path tile. 1 second. So we'll say var, let's just clean that off. Var path, we won't say path tile, we'll say tile equals path tile dot instantiate. Beautiful. Now var tile is of type node 3D, so let's just give that a node 3D there so we know. And then what we'll do is we'll say add child tile, and then finally we'll say tile dot global position. Now this is where it doesn't know what tile is. It's a bit annoying. Equals vector3, and here we're changing the map is a 2D map, so we need to think about the fact that it's 2D. We're actually displaying it in 3D, so we won't go on the Y, which is the up and down, if you like, the height of your 3D viewport. We'll say element dot x 0 element dot y. That looks like that's done it without a fuss. Now if we press play now, I think it's all done, but of course we can't see anything because in our scene we need to add a into camera 3D. Let's get to the 3D zone here so we can have a quick look at what we're doing. And then slide it to the left, bring it up a bit, drag it down. And then we'll also add a directional light. This is going to look pretty terrible right now, but we don't care about that. Okay, and we'll just drag that. We'll tell you what, we'll do something similar with that. Let's click on play and see if it... and there we go. We can actually see the system. Now, what I'm going to do, I'm going to try something here. I'm going to just make that like that. Let's hide some stuff. So bring you over there and bring you over here. Let's try and get the camera correct. I had a few problems with this before. So if I grab the camera and then under the transform here, let's set the scale for a second. Let's set the scale to 120. To me, that looks like that's facing the wrong way. I think it's going... Or maybe it isn't. No, it's completely mashed it up. That is correct, left to right. But it has mashed it up badly, right, going up and down and what have you. So let's just, up here, let's just drag it up. Do you know what? I'm going to go with this for now, just so that we can, no, I'll bring it down a bit. Actually, I can make the field of view a bit smaller, can't I? Yeah, 90, and then change the angle on the X. So it's pointing something like that, and then maybe just make it 8 and 70. Yeah. We're not after perfection right now. Just something that looks like it's going left to right, and it is. You'll have to take my word for that. It is, but you can see the problems that have happened here. We've got one there, and it's gone back down and back up. So we need to think about how we can add some logic so it doesn't go back on itself. And this is quite straightforward, really. If we save this and then go back to our scripts and back to our path generator. So we're going to say. If choice is 1 and we're going to go down, then we need to make sure that there isn't something already there. Right, so if we then say here, and not path dot has vector 2i x comma y plus 1. Right, so what we're saying here is that if we don't want to go down if there's already a tile there. And not underscore path has a vector to y plus 1, then we can do a y plus 1. And I'm guessing we want to say something along similar as here, but y minus 1. And then it's y minus 1. Like so. Right, so we're checking that, if we're going to go up 1, there shouldn't be one already there. Now, for those of you that are, sharp and to the point, you may notice that it's possible that we could actually go through all of these choices here and not hit one, and then it'll loop round. And that's why we've got to get we've got to check to see that we're not adding it multiple times. I was trying to find a unique array actually, so we could just add it, and then it wouldn't automatically add it. I couldn't find a way to do that. If anybody knows a secret way or an easy way, I was looking around at callable functions and stuff. It seemed too complicated. So now if we give it a run, let's have a look, see how it looks. Well, that looks a whole lot better, doesn't it? That looks a whole lot better. There is something that I really like. I don't like the last tile to be pointing. I want the last tile to look right. So what I might just do under the logic here, is it now or x equals, and I think I've got to say grid height minus 1. Grid length rather, grid length minus 1. If x equals grid length minus 1, so if x is 15, then it has to be right as well. Let's just give that a quick go. I think that's correct. Well, it's a good start. Yeah, I think that's correct. Now it's fun. It's okay. What we can actually do under our main.gd here, we can say generate path here, and what we could potentially do is say while underscore path dot size, isn't it? Size is less than 25. Right, so that's how many 25 bits, how many tiles along the path, and then we'll just regenerate it again. Yeah. So it'll just keep doing it. No. We don't need to do that anymore. We just do that. Right. So it's going to create one initially, and if it's less than 25 tiles, it'll do it again and again and again. So now if we run it, there, we've got something a little bit more interesting now. I think 25. You can play around with this. Obviously, there's going to be a sort of if you. I'm gonna zoom in a touch. I could try 35. But you start to run into some dangerous ground because eventually, if you imagine you go up and down, up and down, up and down, there will be a limit. But this is looking okay, if a little ugly. Let's get the let's make that 60. Have another look, and we'll move this along the X to. Actually, what's halfway? Let's try 8. Yeah, that's good. I think we need to move it closer, but that's okay. It's showing up, and we've got ourselves a route that it can take. So I like that, and I think that's all we need for the actual path generation in itself. But we don't want it looking just like a bland old green route here. In fact, to be honest with you, what I'd like to do is I'd like to populate the rest with trees and what have you. And if I just use this, then it would look rubbish. So we'll think about now how we're going to start populating these positions. Let's do that now. I think first of all we need to decide what tiles we're going to need. So let's just exit that there and back to here, path tile. I'm going to rename that. So what I'm going to do is I'm going to call this tile path. Tile underscore let's call it tile underscore straight, which is going to be the straight road, and we'll have a tile underscore corner. I think that's all we need for now, isn't it? Tile straight and tile corner. We'll need to rotate the corner appropriately as we hit it. But let's just do tile straight for now. Tile straight dot instantiate. Okay, I think. Where's the other one? There we go. I must have misspelt it. Right. So now if we go back to our main here, it's probably going to be empty again. Now, so if we look for tile straight, I think it's tile straight. Yeah, tile straight is what we want here. Let's just drag that into the tile straight there, and tile corner. Just got to be a little bit careful on these ones, I think. Tile corner round. Don't go for the large. Or is it tile corner outer? Let's just have a quick. We can. It's definitely not the large ones. Don't get confused with that one. Inner, large, outer. Let's just go tile corner round. Put that in the corner one there. Now, if we press play now, we're going to get all of the straight ones. Now you'll see the first problem that we've got is that it's facing the wrong way. Sometimes it's not. I'm going to zoom that in a little bit. Let's just get the 3D going so we can really get involved now. Now where's the camera? So I think that camera. Where is the camera? I can't actually see the camera. Let's run it again. Camera 3D. Let's angle it down a touch more. So let's try minus 70, minus 75, and then let's just drag this down. That looks better, doesn't it? There we go. Now we're closer, and let's just drag it up a touch. Minus 60. That's about as good as we're going to get. Minus 65 maybe. That's fine. There we go. Right, now we can really see what's going on, can't we? It's looking boring as anything. So we can see sometimes it's correct and sometimes it's not. Now, the way I have designed this is to work out what type of tile we need. We need to look around at the tiles that surround it. Now, what I mean by that is, if we've got, say, this tile here, if there's a tile on the left and a tile on the right, then we know that it needs to be a straight one. Right? If there's a tile to the right and a tile above it, we can see that it's going to be a corner one. Right? And I think it's fair to say that any tile will only have 2 adjacent tiles. Right? It can only have 2. So how do we go about doing that? Well, what we could do is we could score the. We could say, well, if it's got one above it, we'll score 1. If it's got one to the right, it's 2. If it's below it, it's got 4 because we need to be, we need to add up the sums. If it's to the right, it's 8, and that'll give us a unique number. And from that number, we can say it needs to be straight or curved or whatever. So what we can do is now if we just come out of here. Now, do I put this in the? I think it's got to go in the main.gd. I don't think it's got the path generator is for generating a path, right? It's not for defining what the path looks like. But it could get a part. It could get a score, couldn't it? It could get a score. So if we, so this has generated a path. Let's just double check what we're saying here. pg.generate path. Yeah, so the pg does have a reference to its own path. So we can, in here, we'll say, we'll create a new function. So we'll say func get tile score, and then var, hang on, yeah. So int. Oh, we could just do the vector, couldn't we? We could just do the vector. So we'll say tile of type vector2i, and then we will. I think that's fine. And then we can say. No, I'm going to do it like this. I'm going to say so var x equals tile.x and var y equals tile.y, and then we can go through the path and see if those exist. So we'll say if. Do you know what, I might just do something along. I might just do something a little bit GD scripty here. So I'll say we'll have a score, right, and we'll return the score as well. Return score, and then we'll say up here score equals 0. Var score type int equals 0. I think we need to say something like this. We just put here, don't we? Just put int to say it's going to return something. There we go. That looks clean there. And then we'll say score plus equals 1 if it's above it. We'll say that, shall we? If underscore path.has vector2i. So it's above it, so it's my minus 1, right? Vector2i brackets x comma y minus 1. I think you have to say else 0. Does that work? Work for me. It does. Okay, that's a bit of a funky way of formatting text there. I hope that makes. I don't like to make text too complicated, and I hope that isn't too complicated there. So now we can now say, let's just do the same thing. So we're going to say plus equals 2 if it's to the right. So that's x plus 1, isn't it? Or y, and then 4 if it's down, so that'll be y plus 1, and finally to the left it'll be 8 if x minus 1 comma y. Right, I hope that makes sense. If what this is doing is it's looking at the adjacent tiles and it's adding them up, so it's only going to ever have 2 adjacent tiles, but potentially, you know, by adding these up, 12, 14, it could be up to 15, but it's not going to have 4 adjacent tiles. So this is good. This is really good news. And now we can use that get tile score for that element, and then we can use that to define what tile we should put there. So let's go back to main.gd, and now we will say. So we need to define here. So we'll just say element. So we've got that element there. So we can just say. Int var tile score type int equals element was it underscore pg dot get tile score vector2i. So that's going to be the element, because that is the element in the path there, right? And let's just print that off, shall we? Print tile score, because we're getting a little bit deep now. We haven't run it for a while. I like to run often. And they're always 0, you see. So something has gone wrong. Obviously spotted. I should put vector2i. Okay, good. Okay, let's try and run that again. Sorry, remove that. F12. Output here. That's better. We've got some numbers here, right? So we can see what's going on. This is good. So we can go back to our main now. And we've got our score. So we don't need to print that now. And we'll just have, so what scenarios would give us a horizontal tile? Well, let's have a think. It would be ones where it's to the right is 1 at the start. There's only going to be 1, isn't there? So let's just, hang on, I'm just writing this down. Right, let me just do a little comment here, shall we? Hash. Let's do a few hashes. If I can't. Like so, and then we'll say that's 1. What did I end up saying? That's 2. That's 4, and that's 8. No, that's 4. Sorry, that's 4 and that's 8. Right. So if it's 8, 2, or 10, then we need to use a horizontal one. So let's get that correct. So what we'll do here is we'll give it the tile to generate before we do that. So we'll just say, we ignore that. If tile score equals 2, or tile score equals 8, or tile score equals 10. So what I'm going to quickly do, I'm going to have a default one as well. So let's just do a parser. Is that going to be kind? Yeah, it's going to be kind. So up here as well, let's just have a var tile, export var, export var tile empty, right, of type paxing. And then what we will quickly do under main here, let's just look for tile. Just drag that into tile empty. Right, and what we'll do is we'll default it to that tile here, back here where we were. Yeah, and let's just say, okay, so we'll say var tile of type the node 3D equals was it tile empty dot instantiate. Right, so that's going to be the default tile for now. So that's going to have a lot of empty spots, and then we will just say. But if it's these values, then we're going to say tile equals tile straight dot instantiate, and then down here that should well, ignore that bit. Add child tile. All right. So what this should do now, I think, in scenarios where it's a straight line, it'll be round the wrong way. But let's just see if that works, and then it'll put it in the right position. Let's just see if that's working. Var tile of node 3D equals tile empty dot instantiate. Can't quite see what. Could not find type node. Oh, it's because it's 3D. Excuse me. Let's run it. This is good. This is really good. You can see in scenarios where it should have been right, but you can see it's the wrong way around. So what we'll do as well is we'll add a thing called tile rotation here. Var tile rotation. And this is going to be of type vector3 equals, and then we'll just say vector3.0 for now. And then here we'll just say tile rotation, equals vector3 bracket 0, 90. We'll use degrees here, 0, right? So we need to rotate it 90 degrees. And under our global position, we'll say tile dot global rotation, and I'm pretty sure you can say degrees here, equals tile rotation. So if it's a scenario where it's a straight line, we're going to use the straight tile and set the tile rotation to that. Let's just give that a go. And that's worked. That's absolutely worked. That's tremendous. So now let's just do the vertical ones. So let's just so we'll just say elif tile score equals, so it's going to be 1, 4, or 5, isn't it? 1, or tile score equals 4, or tile score. I don't think it can ever equal 1 or 4. The reason it could be 8 or 2 is because it's either end of the left and right. I don't think it can be 1 or 4, but maybe it can. And then we're basically the same thing, right? That, and then we'll just say vector3 0. We'll just keep that as 0 just for consistency, so that we can see, and that should create our horizontals. Let's have a look. Oh, boom! It's done it. Look at this. Now all we need to we've got 4 scenarios, right? All of these different corners. So let's just start maybe with down and right. So down and right is, but from our here, 8 and 4. So if this tile is in the middle here, it's got 1 to its left and 1 to underneath it. It would be 12, wouldn't it? So let's just say elif tile score was 12. Right. So it's tile equals tile corner dot instantiate. But we don't know. We don't currently know the rotation, do we? Well, let's just copy that. You never know, we might be lucky. Let's just run that. Okay, and click on here. No, it's not correct, is it? So I think we need to rotate it 180. That is not correct. Maybe it was 90. Maybe it was 90. It is 90. This, can you see that's gone down nicely now? Let's do this one here, which is, what's that? That is, so this tile here would have one below it and one to the right. So let's have a little look at that. That would be score 6. One to the below it and one to the right is 6. Okay. I don't know if we should do this in any order, but maybe I will just put that above it just to keep it in some sort of order. Elif tile score equals 6. That's exactly what one here, isn't it? You could almost maybe do this slightly differently, maybe. And let's just try 0, 0, 0 there. Just see how that goes. No. Now, I'm going to say it's 180. I'm going to try 180. It is 180. We're there. We're almost there. We're almost there. 2 to go. And then we will have Elif. What was it? Is it still running? No, let's just quickly give it a run. What's happened? What did I do wrong there? Oh, yeah. I put code in, didn't I? So let's do 9, which is up, which is one to the left and one up. So we do 9. Elif tile score. Oh, nice. Tile score equals 9. I might reorder these so that they're in order, but tile corner, and let's try 0 now. One of them's got to be 0, isn't it? One of them's got to be 0. And I think it is. And that only leaves this one, which is up and right, which is up here. 3? Up and right, yeah, 3. So 3. So guessing it's got 0, 180, 90. Sorry, 180, 90, 0. So this is probably 270 or maybe minus 90, depending on your thoughts. Let's have a look. We've done it. We've absolutely done it. Look at that. Now that is a quality path, and it's random. Look at that. Look at that. One thing I would like to do maybe is have a sort of a circle spawn either side. So let's quickly finish that off now. So let's up here. We'll just say we'll add another one called tile. We can let's create 2. Export var tile start. They might be the same right now. I've typed packed scene, and then tile end. Now, thinking about this, actually, the tile at the start only has one to the right of it. So that would be 2. And then we've got this here. So let's just put that here. So we'll say if tile score equals 2. All right, and then we'll just say tile equals tile underscore start dot instantiate. And I have no idea what rotation to use. Let's just go with that for now. All right, and then we can just remove tiles 2 from there. Yep. If tile score equals 8 or 10, right? Okay, yeah. And we'll need to populate that as well. Back to main we go here. No, main here, and we need to find a start. I think it's called spawn on this. Tile spawn.glb. Right, so that one there. Let's have a look. That's not the one I want. I want a tile spawn round. That's what I want. I think that's what I want. Let's try it again. No, that's just around. I want one that's edged off here. 1 second. Let me find that. Okay, I think it's tile end round spawn, which is a bit confusing, isn't it? Because that's the start. But so if I just run that now, it might be around the wrong way. It is. We need to flip it 180. So let's do that. Oh no, hang on. It's on 0. Let's just have a quick look. Let's try it. Yeah, we need to turn it one more, don't we? So minus 90? Or 2, let's do minus 90 on this one just for confusion. Yeah, I think you can do it. There we go. That's good. And we can do the same for this right-hand one, right? Because it's only going to ever have one to the left because of that rule we had earlier on. So we can say one to the left would be 8. which does make sense because that's the other thing we've got. So so elif, yeah, we put elif there as well, don't we? Elif. Let's copy this whole thing here, and then we'll just do that equals 8. And finally, I think, yeah, so now we can get rid of the 8 here. And that's probably going to be 90 then, isn't it? Based on the fact that it needs to be the other way around. Let's see. There it is. Look at that path. Look at that path. How amazing is that? Yeah, I really like it. I think perhaps just for completeness, to finish off this video, we will fill out the rest of the blanks. So the way we're going to do that, so that was the display path. In fact, if we're going to display the path, then we probably need to let's just hide that for now. We'll get rid of it for now. That's created all of the elements and displayed them. Lovely. I might just put that in its own function. How about that? So display path is fine. And then what we'll do now is we'll have another method called complete grid or something like that. And then func here, complete grid underscore complete grid. And then we do something like this here for element in path. No, yeah, from no, we don't. We need to go x and y, don't we? So for int I in range underscore grid length. We should map length. Why are you being unkind? Map length, no underscore. Map length. And that needs to be for x, doesn't it? For x in range map length. For y in range map height. And then we'll say if not underscore path dot has the underscore path. What do we call it? PG. Right. We need to think about this, then, don't we? Hang on. So we need a function in here called getPath. Let's just have that here now. Func. So we'll just do that here. Func getPath returns an array of type vector 2i. That's going to return underscore path. Old school. And then we can go back to the main here. So we can just say if not pg dot getPath. No. Did I do that wrong? What did I do wrong here? So underscore pg dot getPath is there. Look, dot has vector 2i. I know we need to change that in a second. X comma y. There we go. That's it. So we're going to say if not pg.getPath has, right, so there's nothing in the path for that value. Then what we can then do is we can say var tile of type node3d equals, and it's up here, isn't it? Tile empty dot instantiate, and then we will add child Tom, and we will tile dot global position equals vector 3. Again, it's going to be x comma 0 comma y because we're not going up. Crikey, complete grid. How about that? Now that might work. That was a lot of text for one go, wasn't it? Okay, it's failed. Could not find type. No, I've done it again. I spelled no 3D. Okay. Yeah, whatever. Let's just stop and restart. There it is. Now, see what problem. It seems to have gone below it. So I think we need to say, and also it's gone right to the top as well. So let's just sort that path, the path generator out, so that it doesn't do that anymore. So we want the y to be not to be greater than 0, but let's make that greater than 1. And the grid height, then I guess that's -2. That will stop it going too low. It's a promising start. We need to move that. We need to move it across a little bit, don't we? The camera, but not much. Okay, click here. This is looking tremendous. How about that? And every time you run it, you'll get a different unique map. We can adjust the size. Should we just make it bigger? Let's make it. Well, we can go into the main here, can't we? And let's just change let's change that to 24 by 13. Let's run it. It's going to be much, obviously not going to fit, but there we go. Look at this; it's on its way. So we can easily adjust this. And if I just click on that and click on that, we'll just set it back to what it was. And how about that? A procedural path. And you'll see what I mean. So the gap here that can be used. You see, if I didn't have that, then you can see there might be a little bit of a problem where it could get messed up. I think it just looks a little cleaner. It's a little bit lazy, I think, doing it this way, but it does work. The one thing that I haven't done yet is the crossroads, and theoretically we could create a little loop here. Maybe just there, no, probably not, but not in that example. But there's always the opportunity, I think, that we might be able to pop a little crossroads in there. So in the next episode, alongside generating some proper assets that are going to, populate this area, we'll work on crossroads as well. Thank you so much for watching this. How long has this video been? I can't tell. It's been 1 hour long. So thank you very, very much for watching. I've realized now that, oh, hang on. There we go. There's a little bit of green screen coming through. Sorry about that. I hope that was useful. I hope you find it. Please like, comment, subscribe, all that good stuff. I will edit this down, speed it up a little bit. Actually, it'll be less than an hour because I'll speed it up. Thank you very much. Until next time, folks. All the best. Cheers.